Welcome everyone. In this walkthrough, we'll look at a question involving equilibrium constants in terms of partial pressures. Kp can be used to express the position of an equilibrium quantitatively rather than just saying that equilibrium lies to the left or to the right. I'll explain how to calculate equilibrium amounts, partial pressures, and derive the Kp expression. We will use this expression to calculate a value of Kp with units using data provided. Here's the format for the walkthrough. It's an AQA A-Level Chemistry Year 2 past paper question. Details are in the description. Let's get started. Here's the first part of the question. The sum of the mole fractions is always equal to 1. Nitrogen and hydrogen are mixed in a 1:3 ratio, and they also react in a 1:3 ratio. This means that the ratio of nitrogen to hydrogen in the equilibrium mixture will always be 1:3. We are told in the question that the mole fraction of ammonia in the equilibrium is 0.80, so the sum of the mole fractions of nitrogen and hydrogen must be 0.20. The mole fractions of nitrogen and hydrogen must be 0.05 and 0.15 respectively, since they are present in a 1:3 ratio. Partial pressure is calculated by multiplying the mole fraction of each substance by the total pressure. The partial pressure of each component in the equilibrium mixture is shown here, and this part of the question is now complete. Here's the next part of the question. The Kp expression is a fraction. The numerator is found by multiplying the partial pressures of the products. The denominator is found by multiplying the partial pressures of the reactants. The Kp expression is shown here, and this part of the question is now complete. I have used pp to denote partial pressure. The brackets around each component help to make expressions clear, especially with terms that are raised to a power. Here's the next part of the question. Use the Kp expression that was derived in the previous part of the question. Next, substitute the partial pressure values into the Kp expression. These are given in the table. Kp works out to be 2.99 times 10 to the minus 3. I have given the answer to 3 significant figures, the same as the data given in the question. Each partial pressure has units of kilopascals. There are 2 terms in the numerator and 4 terms in the denominator. The units for Kp are kilopascals to the minus 2. And here's the final part of the question. Le Chatelier's principle can be summarized as equilibria shift to oppose change. You should have encountered this concept in Year 1. When temperature is increased, the equilibrium will shift in order to decrease the temperature. The equilibrium will shift to the left towards the endothermic direction. The amount of ammonia, and therefore the partial pressure of ammonia, will decrease. The partial pressures of hydrogen and nitrogen will increase. If we look at the Kp expression, we can see that the value of Kp will decrease. Thanks for watching. Please post in the comments if you have any questions or suggestions. Take care and good luck with your studies.